So hello everyone, this is Yashwan and today we are talking about linear regression. So first of all, we will understand where linear regression stands. So linear regression is a ML algorithm that comes under supervised learning. It means we give label as well as data together while training it. In supervised learning, there are two categories. One is classification and the other is regression. So, our linear regression, as its name suggests, it comes under regression because it is related to the prediction of numbers. That is why it is under regression. So now we will understand what is linear regression. So linear regression is a type of model that predicts the uh, is a type of model that predicts the the relationship between input variable and the uh, output. Means it will define the relationship between dependent variable and independent variable. So linear regression are the graph of linear regression looks like this. So here the dependent variable is city miles per gallon and the independent variable is weight of car. So so we define the relationship between dependent variable and independent variable with a linear linear graph. You can see straight line here. So we define the relationship with a linear graph, that is I call linear regression. So linear regression has two types: simple linear regression and multiple linear regression. So linear regression means the input is only one. So the dependent so x is the input variable, means it is the independent variable, and y is the dependent variable because it is dependent uh, on x for its value. So in simple linear regression there is only one independent variable and one dependent variable. So the question arises, what is this B naught and B1? So it is basically the weights. B1 is the weight uh, that defines how important the input is, and B naught is the interception, means where the graph line uh, collides with the y-axis. It tells that. Okay. In multiple linear regression, there are multiple inputs. For example, this x1, x2, up to xn, n number of inputs there are. B naught is the interception, and B1, B2, Bn, these are weights. They define how much importance the input has. For example, if the B1 is uh, is larger than B2, then x1 input is more important than x2 input. So that is how it defines relationship and makes such graphs. Now we will go to the coding part and understand uh, how we can implement linear regression in our Python code. So this is the code that I have written. Uh, uh, So to start, before start implementing this, we have to import it from the libraries. So that is why we will import all the libraries of our code, which is NumPy for basic calculation, a matplotlib to plot the graph. Later we will plot the graph. So that is why we have called matplotlib pie plot, which is named as PLT. Then we have called iris data set, load iris, which is called, which is in data sets of sklearn. Sklearn is a library which has multiple types of sub libraries, and one of them is data sets. And from there we called load iris. Then again from sklearn we from model selection, one more sub libraries we imported train test split. Then from sklearn linear models, where are multiple type of models such as logistic regression, linear regression. We call linear regression that we are using in this code. So load iris is stored in a variable called iris, and the data, the input is stored, the, the features are stored in x, and the target are stored in y. uh, and then the target and as well as the data is splitted for in x train. So the this x is splitted into x train and x test. This y is splitted into x, no, y train and y test is equal to train test split that we have imported. So this helps us splitting the data set into two parts as well as the target with it. So xy we have splitted, and the test size is 3, means testing data will be 30% and training data will be 70%. Random state is 23, means the pattern of randomization is will be 23. Training model, uh, so we have stored linear regression, our model, into a variable called model, and we have fitted the values of x train and y train, which we will giving the model to train itself. And then after the training we are making it to predict. So uh, ypred is a variable that is uh, storing the value of model's prediction of x test. First we have given it data to get it to trained. Then after completing its training, now it's time for the model to predict the value. So we are giving the x test data that we have separated from x training data. Now after giving x test data we are saying to predict it. After the prediction, we are plotting this data into graph. So we have told to scatter the value of y test, which was um, which was the comparison, means हमें compare करना है y predict को और y test को ना. सो हमने इन दोनों की वैल्यू दे दी है और स्कैटर करने बोल दिया है, तो इसने स्कैटर कर दिया है. और फिर प्लॉट भी करने बोला है हमने एक्स और वाई को, मतलब ये दोनों का डेटा सेट एक ही हो जाए, इसलिए हमने ऐसा कह दिया है. फिर वाई लेबल दे दिया है हमने, एक्स लेबल दे दिया है और टाइटल का नाम दे दिया है और शो बोला है. शो मतलब एक तरह का प्रिंट ही, कि प्रिंट करके दिखा दो. और ये कुछ ऐसे टाइप का प्रिंट हो रहा है. ये आइरिस का डेटा सेट है इसलिए ये ऐसा प्रिंट हो रहा है, वरना हमने ग्राफ देखा था वैसे टाइप का लीनियर रिग्रेशन में जनरली ग्राफ्स प्रिंट होते हैं. जैसे हमने देखा था इस टाइप का लीनियर रिग्रेशन में जनरली ग्राफ्स प्रिंट होते हैं, और इसी के बेसिस पे हम प्रिडिक्ट करते हैं कि मॉडल कैसा है या फिर जो भी उसके आगे करना होता है. So thank you up to watching this. You can check out my blog that I have written, and if you want to understand this topic line by with point wise, then you can check my blog. I have written it in that way. Thank you.